Question number 5. In an AC circuit, the supply voltage is given by the equation V is equal to 240 sine 5000 T plus pi over 2. This is volt, and the current is given by the equation I is equal to 0.480 sine 5000 T. Okay, so number 1, what is the mean of root mean square? Root mean square, or RMS, for the current, or RMS, if you relate to the DC circuit, Rms current, okay, Rms current actually is equivalent to the DC current, the value of effective current. Or if you look at the Rms equation, you have I naught divided by 2. So I naught is the maximum current. If you look at the sinusoidal graph, because this is current I and this is time t, the value of the current is always changed at the time t. So this is a V naught here. So you can find the I naught here. So you can find the value of the RMS by calculate or find the value of the I naught divided by square root 2. Okay, next is number 2. Calculate impedance of the circuit. So for the number 5, you have equation or voltage V and equation for the I. This is a sinusoidal graph. So for the Z, or if you look at the V is equal to IR for the AC current, or V naught is equal to I naught, this is number 2, I naught divided by R here is a impedance Z, meaning the impedance Z is equal to V naught divided by I naught. If you look at the value of the this is for the voltage, actually this is a V naught, and this is equal to I naught. So I naught and V naught is come from the equation given by the question. So V naught 240 and I naught is equal to 0.450. This is, if you use the calculator, is 500 ohm. Okay, number 3, sketch partial diagram V and I. So if you look at the equation here, for the I and V, so this is a sinusoidal graph, but this is for the V here we have a plus pi over 2. So now for number 3, stress partial diagram. If you draw to the partial diagram, meaning V need I with the pi over 2, or this is the angle here is a pi over 2. Okay, so and state electric component, either RCL, RC, or RL. So RCL circuit meaning you have in the circuit you have a resistor, you have a capacitor C, and you have a inductor L. So this is RCL circuit. So for the RC circuit, so this is you have only R and C. For the RL, you have only resistor and inductor L. So according to the partial diagram here, so we lead I pi over 2. So meaning this is look at the partial diagram. So V and I here, so meaning this is refer to the RL circuit. So meaning in the circuit here you have only R and inductor L. Okay, so number 4, calculate instantaneous and maximum power dissipate. So how to calculate the instantaneous power dissipate? So this is number 4. So look at the equation for instantaneous power, or P instantaneous, is given by the equation IV, right? The value of the IV. So what is the value of the IV here? So you have this is value of the I at the time t or instantaneous t, and you have a v here for instantaneous. So you put the value of the I here and the v here, so you can find the instantaneous power. If you use the calculator, have the final answer is, so no, because instantaneous power meaning because you have the the answer in the time t, term t. So I have write the final answer here. So this is 57.6 sine 1000 t. So this is a automatic process that you can find the P instantaneous power. Okay, and the next is a P maximum. So right here, so P maximum, you just use equation P maximum is equal to I naught V naught divided by 2. So if you look at the equation, so this is V naught and this is I naught. So meaning you have a I naught is equal to 0.480, V naught is equal to 240 and divided by 2, right? So P maximum is equal to 57.66 watt. Next question, number 5b. A resistor 6 ohm and capacitor, this is R is 6 ohm, and capacitor C is equal to 3000 microfarad, and the inductor L is 5 millihenry. So meaning you have a R, you have a C, and you have L, meaning this is a RCL circuit. Meaning you have a, in the circuit you have R, you have the capacitance C, and you have a inductance L. So this is for the AC circuit. If the source of the frequency, source of the AC source is 50 Hz, and the peak value, or this is a V naught. V naught peak value is a V maximum 240 volt is connected combination. Calculate total impedance. So number 1, if you want to calculate the total impedance, you can use the equation Z is equal to square root R square plus XL minus XC, right? So all the value for here, you have a resistor, here you have a 6, this is square, right? So this is a reactant, inductive reactance. So this is equal to 2 pi FL, and this is capacity reactance. This is 1 over 2 pi FC. So if you look at the value for the L here is equal to, this is 5 millihenry, and you have the frequency is 50 Hz, and now you have a same frequency 50 Hz, and then you have the capacitance of the capacitor is 3000 microfarad. So if you use the calculator, you can find the value of the Z here. So right here the Z is equal to 6.02 ohm. So our next question is resonant frequency of the circuit. So as you know, at the resonant frequency, XL is equal to XC, or because if you get the impedance equation, Z is equal to R square plus XL square minus XC square. So when the XL is equal to XC, meaning this is equal to 0, or this is Z is equal to R. From the equation here, because XL is equal to 2 pi FL, and this is XC is equal to 1 over 2 pi FC, meaning if you want to calculate the resonant frequency here, what is the value of F? You can use the equation F, or resonant frequency F naught. This is, say this is F naught. F is equal to 1 over 2 pi square root LC. So you just put the value of the L here, L is equal to 5 millihenry, and C is equal to 3000 microfarad. So you can find the F naught resonant frequency is equal to 41.1 Hz. Next equation is what is energy dissipated during the resonance. So as you know, when the resonant frequency XL is equal to XC, so when the XL is equal to XC, meaning the Z or impedance is equal to R. So at the point here, when Z is equal to R, meaning the Z here is a minimum. When the Z minimum, current flow or Irms in the circuit is maximum. So when Ri is maximum, the energy dissipated here is a energy dissipate here is a maximum, right? So that's all. Thank you.